It is 9 o'clock, so I'm going to get started. There's a problem with the homework assignment. One of the questions, I found out what the problem was. I think some of you experienced that one. It has to do with the x plus equal to, in parentheses, x plus equal to x itself, okay? So that's the one, or x plus equal to 1 inside. That one has a problem because when Moodle came up with the random numbers, it did not know that those are supposed to be integers, so it came up with fractions, or not fractions, but it came up with numbers with a decimal point value, and that's why some of the answers are wrong. They're off basically. They're not wrong, but they're off. So I have re-engineered that particular question, and I'll extend the deadline of the homework assignment that was supposed to be due right now to at the end of the lab time. So if you guys want to retry that, you can go ahead and do it. It's not done yet, so let me log in first, and I'll go ahead and show you which question I'm talking about. And then we can start to talk about the actual homework assignment that was assigned on Monday. And if you guys have any questions, I can try to answer that. So that one is in basic syntax, and it's the last one. It's the second quiz in here. It's called more operators. And one of the questions has a problem, and I'll show you which one I'm talking about. The quiz is now over, but I can edit the settings, reopen it, so that you can turn in another one, or another attempt if you want to. So we'll close the quiz at, I'll just put it at noontime, so you have 3 additional hours to work on it. You can certainly do that during the lab time. Okay. And I'll show you which question, because you may or may not have a problem with that one, okay? If you have a perfect score already, don't bother, okay, you're fine. But if you want to retry it, because you didn't get quite a perfect score, or if you want to really understand what that question is, even though you got the right answer, but you want to know what is the actual answer, you can do it also. And I'm gonna show you which one we are dealing with. It's, let's see, edit quiz. And it has to do with the nested compound statement. This is the one. I'll show you the question. This is the one. The form of the question is, it will ask you to assume x has a particular value already, and it will ask you what is the value of x after the following expression. And the expression looks like this. Okay, so this is the question that has an issue with the automated answer, because some people reported and have verified that sometimes an odd number as an answer is taken as the correct one, and other times it's an even number. And it has to do with when Moodle came up with random numbers for x, some of those numbers are like 7.5, 7.2, and that's why it came up with the wrong answer. So I have fixed it already, and it should be working correctly now. So if you did not get a perfect score out of the quiz, you can reopen the quiz, do another attempt, and basically get another chance of getting a perfect score out of that particular quiz. Are there any questions about this?
I have actually a question about the quiz.
Yep.
We have the question that says x plus plus comma plus plus x comma x plus equals x.
Yes.
Alright. Could we go over that one?
Well, I can point out where you can find information about that one. I'm not so sure about going over it.
Yeah.
Okay. So that one has to do with a comma operator. The comma operator is the one that is tricky, and that one is in ternary and unary operators. When we talked about the unary operator, I commented here that I just kind of sneak in a particular operator here. So that's the section that you have to read. I also ran an experiment in class. Some of you may or may not remember. I think it goes like x equals to 1, comma 2, comma 3, comma 4, comma 5. And then I ran it in GDB, and after the assignment statement, I took a look at the value in x, okay? So that's also the other one, the other thing that you might want to recall in order to answer that particular question. Okay? All right. So, any other questions? Yep.
On number 4, I kept getting it wrong. I thought I had it right.
What type of question is it? Because you
I forget what the symbol means, but the one with the
carrot. Well, then you need to look up what that symbol means first.
I did.
Right? Okay. So that one has to do with, it's a bitwise exclusive OR operator.
Okay.
So you have to go into logical versus bitwise operators.
I was typing it out like a byte, like a binary number, and it wants base 10, I guess.
Right.
So that's
Yeah,
why-
if it doesn't ask you for a base 2 number, it is in base 10. Yep. I would have made it so that it would accept both, base 10, base 2, and whatnot, but that's not one of the options I can specify.
Okay.
Yep. Any other questions? No other questions? Okay, so the quiz is now reopened, so if you want to make additional attempts before noontime, you can do so, but it's only up to noontime, so the extension is only up to 12, basically at noon. Right, so with that stuff out of the way, we can now start with control structures, okay? So that's kind of useful stuff, okay? Control structures tend to be useful, but a lot of this is also repetition from what you have learned already in CISP 300 and 301. So do not be surprised, if you already know most of this stuff. It's just the syntax that might be new to you because it depends on how CISP 300 or 301 was taught. You might be learning C syntax already. You might be learning Visual Basic syntax. You might be learning Pascal syntax, or you might be learning might have learned pseudocode syntax. So it all depends on who taught CISP 300. All right, so we'll start with something like a conditional statement. Okay, so a conditional statement starts with a comparison, and I can see now that I have to reorder some of the topics and move this a little bit before this section here. So we'll go ahead and start with the first part here. In a previous class, which talks about expressions, you should have learned what conditions evaluate to Boolean values. This means when the condition is evaluated, it provides a value that is either true or false. So we talked about that part a little bit already. That in C and C++, what is considered to be true is just non-zero. Non-zero is considered true, 0 is considered false, okay, as a condition. Is that okay? All right. And conditions form the foundation of all control structures. In other words, when we talk about a quote-unquote control structure, it simply means that it is a way so that you are not executing statements in a strictly sequential manner. It's not just 1, 2, 3, 4, 5, 6, and I'm done. Okay, it is a control structure allows you to change the path of execution, so it is not just sequential. Okay, that's it. But why does that have anything to do with conditions? Because, well, if you are going to 1, 2, 6, 5, and then 3, 4, or something like that, well, that's still sequential if that is always the way you take the path. Okay, so that's why with a control structure, with most control structures, what you want to do is to specify a condition so that sometimes you do it this way and sometimes you do it the other way. And that is the nature of all control structures in all programming languages, not just C and C++, but all programming languages. The most basic conditions are based on comparisons. How do you relate a particular value to another value? And these things you know already, okay? In your previous class, you probably talked about, the instructor probably talked about less than or equal to, and it has to be written this way. You cannot reverse the equal sign and the less than symbol, because you have to specify less than first and then the equal symbol. We have greater than or equal to, we have equal to, and then we finally have not equal to. Now, there are 6 of these what we call relational or comparison operators, but what you really need is 1. Okay? If I give you less than or greater than, you can make all the other ones. Is anyone convinced that you only need 1 of these 6? Like a single less than, a single greater than, or if you prefer, you can have a less than or equal to, or greater than or equal to. Any one of those is enough to make the rest. Okay, well, let's take a look. Okay, let's just go through an experiment just to see how well you know the comparison operators. All right, so let's say we only have less than. Okay, so this is a weird programming language, and the only comparison operator the language supports is to say, well, I can tell you whether a particular value is less than another value, but that's it. Okay, there's no built-in equality, not equal to, greater than or equal to, and so on and so forth. This is the only thing I can tell you. Okay, so we'll take a look at, can we express all of the other ones using just less than. Okay, so we'll start with something that's trivial. X is less than y is, oh, guess what? X is less than y. Perfect, easy. The other one that's easy is x is greater than y. Well, we can just exchange the position of the two sides, and it becomes y is less than x. It means exactly the same thing. So these two are kind of trivial. And then we'll move on to something that doesn't look as trivial. Okay, x is less than or equal to y. But when you say x is less than or equal to y, you're basically saying x is greater than y. Well, I should say x is not greater than y. But x is not greater than y means it is not the case that y is less than x. Would that be meaning the same thing? Okay. Now, yes, it is kind of like an indirect way of saying it, but it's exactly the same thing. So now we also know how to express, why x is greater than or equal to y, because it's kind of symmetric. You just say it is not the case that x itself is less than y. All right. So we have handled, most of the easier ones. What about x equals to y? Now remember, in C and C++, when you want to express equality, you have to involve 2 equal symbols, not just 1. What happens when you have only 1 single equal symbol? What does it become?
Assignment.
Assignment, exactly. And we can stick an assignment where a condition is expected, because a condition is nothing more than just an expression. It's just that how we interpret the result of the expression that makes it a condition. If it's non-zero, it is true. If it is 0, it is false. Okay. So what about equality? Sounds like it's a little bit harder to deal with this one. So we'll deal with something that's easier first. What about x does not equal to y? If x does not equal to y, and we are talking about integers, numbers, okay, what is the other way to say that x does not equal to y? Only using the less than operator. Yep.
X is less than y, or y is less than x.
Exactly. Good job. So this is basically x is less than y, or y is less than x. Well, equal to is the opposite of that, right? So the laziest way to do this is to just say, well, not that. Right? We're done. So from one single comparison operator, but utilizing the other logical operators like and not, we can now come up with all of the other comparison operators. So this is the kind of thing that we should think about when we think about programming, is really just to say, well, how many of these things are actually necessary? Can we come up with the other ones from the really basic one? Now, obviously, this is not C syntax, so if you want to convert everything to C, C++ syntax, we put an exclamation point here for negation, and then or is 2 vertical bars, and an exclamation point here. And this is also partially why C and C++ is not really suitable as a beginner's language, because the exclamation point and the vertical bar, from a distance at least, they look very similar. But if you spell them out as not versus or, hey, that's pretty clear what they are. Okay. Are there any questions about what we have on the projector at this point? No questions? This is all good so far? All right. And then the notes talks about how C and C++ do not really have quote-unquote Boolean values, okay? Because any expression that is non-zero is false. Any expression that is non-zero is true. Any expression that is zero is false. Okay? And that's basically what scalars or Boolean values is all about. So we talked about this already. Do we have any questions? Okay, if in case I skipped some of these things earlier and I actually did not talk about this, let me know. Okay, but are there any questions about scalars as Boolean values? In other words, non-zero is true, zero is false. We kind of talked about this when we talked about ternary operators, which is what you need to do your homework assignment, the one that is due next Monday. And how many people are done with that homework assignment already? Yep, good job. Okay. Get it done, get it out of the way so that you can just make room for new stuff. Okay. Okay, so now the question is, well, if non-zero is true, so what exactly is the value of this expression, 3 is less than 4? That is a legitimate question, right? Because in your previous class, we know 3 is less than 4, constant 3, constant 4 will give you an end result of true, T-R-U-E, in most other programming languages. But in C and C++, 3 is less than 4 will give you a value that is simply non-zero. So that means 3 is less than 4, depending on the compiler, depending on many other factors, can be 1. Okay, 1 is non-zero. Can be -1, because -1 is non-zero. Can be 56, because 56 is non-zero. In other words, you have no idea exactly which integer or what value 3 is less than 4 is going to return. The only thing you can count on is it is non-zero. That's the only thing you know about 3 is less than 4, is it is non-zero. Are we still doing okay so far with this stuff? Okay? No questions? And then we talked about the Boolean operator. I reordered the topics a little bit, so that's why we are revisiting this, because we have talked about this already in truth tables of logical versus bitwise operation. So are there any questions about logical AND, which is ampersand, ampersand, logical OR, which is bar, bar, and logical NOT, which is an exclamation point? Any questions about those? No questions? Right, if there are no questions about this, we're going to move on and talk about expression statements, which is something that we have used already. An expression statement is simply an expression followed by a semicolon. That's it. Okay, that turns it into a statement. And if you look into the syntax here, this is a fairly common type of expression, which turns into an expression statement because of the semicolon. Without the semicolon, it is just an expression. With the semicolon, it is now considered a statement. So syntactically, it is just it's moving up one rank. So instead of looking at this as an expression, we can now look at this as a statement, because certain things require a statement, not an expression. Okay. But what about other type of expression statements? Because after all, any expression can be turned into a statement just by appending a semicolon at the end of it on the right-hand side. So that makes 6, which is a very simple expression. Okay, it just evaluates to the constant of 6. But what about 6 semicolon? Is that a statement? Yes, it is. Is it syntactically correct? Yes, it is. Is it useful? No. Not in C and C++. In some other programming languages, each statement also has a value, like Perl has that feature. So in Perl and some other scripting languages, that is actually meaningful, but in C and C++, is not meaningful. Okay? Because I want to make sure that you understand, it doesn't do anything useful, but that's only in C and C++. In other programming languages, it can still be meaningful because the standard is different. All right. So are there any questions about expression statements, the simplest type of statement in C++, which is basically just an expression with a semicolon? But here's a question. What is the simplest type of expression? Well, I mean, 6 is pretty simple, right? Can it get any simpler than that? Go ahead. Just a single semicolon, exactly. A no expression. A no expression is no expression, and if you put a semicolon after nothing, it becomes a no statement, which is also a statement. It doesn't do a single thing, but it is a statement. Very good. Good job. And the no statement seems like a completely useless, feature, quote unquote feature in C and C++. But as we'll see later when we deal with loops, that can be very confusing sometimes. Okay, where you put a semicolon can be extremely confusing, and it can cause problems too. So now that we are done with expression statements, the next one up is called a block or compound statement. We have seen those already as well. Okay. A compound statement or block statement, you can choose to call it either way, is simply a block that starts with an open curly brace, a whole bunch of whatever statement you want to stick inside, possibly none, and a closed curly brace. That becomes a block statement. So what this means is a block statement is not necessarily any more complex than an expression statement, because you can have an empty block statement, open curly brace, nothing in between, and then close curly brace. It is still considered a block statement. Okay? It sounds like it's useless. Okay? Why would anyone make an empty block statement like this with nothing inside? Well, it has its own purposes. Okay? It has its own value of existence. We'll talk about that later as well. So right now, what we have done so far, and the next one I think is a conditional statement. So what we have done so far is to talk about the basic building blocks of statements that do not really change the path of execution. It's just, here's an expression, we evaluate it, and here's a block statement, we evaluate all the things inside the block statement as they're specified, in the order they're specified. Any other questions? No other questions? Okay. Let's take a look at conditional statements. Okay. A conditional statement is the first kind of statement that we have talked about here that can change the path of execution. And the syntax of a conditional statement in C and C++ kind of looks like this. Okay, it starts with an if, which is a keyword. You have to type if the way it is specified. You have to have an open parenthesis. And then you have an expression. Whatever expression you want to specify needs to return a value. The value only has to be something that can have a 0 or a non-zero. In other words, it can be an integer, can be a 16-bit integer, can be a 32-bit integer, can be a 64-bit integer, and when we talk about floating point numbers later on, it can also be a floating point number. It just has to be something that can be 0 or non-zero. The close parenthesis to close the open parenthesis. This is the then block. There's an else word here, and then there's the else block. This is the way I recommend that you write a C statement, I mean a conditional statement. The actual syntax of a conditional statement is a little bit different from what I described here. Okay, this is not the actual syntax of a conditional statement in C++. And I might have forgotten to specify the actual syntax in C++. Let me see if I described it here.
I think further down.
I'm looking for a description of the actual syntax. Okay. I'm going to do it here. I'm going to do it inside the text block here. Okay. So what I'll do here is I will talk about the actual description of the syntax of a conditional statement. I will integrate it into the notes later, so I will type it in. Okay, it goes like this. If, open parentheses, and I'm gonna use this type of notation, which you will see in many description of syntax. So I'm gonna do it this way, and I'll explain what those things are. So this is what we call the then statement, and then we have square bracket else. Okay, so just give me a moment to write this, and then I'll explain exactly what I mean by this stuff here. Okay, there we go. All right. This is called, what we call Mettre Syntax, because this is a description of a syntax. So the syntax to describe a language, to describe another syntax, is called a Mettre Syntax. Okay, so let me just describe what this means. Whatever stuff you see that is not inside a angle bracket should be typed the way they're specified. Okay, but when you see open square bracket, that also has special meaning. I'll talk about that later. So if it's not inside any type of square bracket or angle brackets, so this is required, and you have to type it verbatim, which means if is what you need to specify to start a conditional statement. The open parenthesis, same way, okay? You have to type an open parenthesis with every single conditional statement, and it has to go after the the if. This space here is optional, okay? You can leave no space, but it does make it easier to read. What about this thing here? Okay, I don't remember. C has a syntax like that in HTML. Well, what angle bracket usually means when we describe a syntax is it's just a token. It's a placeholder. So in this case, EXPR, which stands for expression, is really just a placeholder for an expression that you can replace later on. Okay, so that expression can be something as simple as 1 or 0. Okay, or it can be this long as an expression with and or not and all kinds of other stuff. Okay, but it just has to be an expression that can return a value of 0 or non-zero. So this is called a token, or otherwise known as a placeholder. The close parenthesis has to be here as well. And then we have a single statement here. In other words, you can only specify one single statement of what to do when the expression is true. It's called a then statement because this is what you execute when the condition evaluates to non-zero. Are we still doing okay so far with the syntax description? Still okay? Any questions about this part? Okay. What about the square bracket here? Well, the square bracket in syntax description typically indicates something is optional. Okay? In other words, it can be here, it doesn't have to be here. So this means that the else portion is optional in a conditional statement in C and C++. Okay? But since I put the open square bracket all the way here and the closing square bracket all the way here, that means if you have the else portion, this portion has to be here. You cannot just have the else without the else statement. If you have the else, you also have the else statement. Okay? So the else part, which is optional, starts with the word else itself, E-L-S-E, so you have to spell it out the way it is specified here. And there's only one statement you can specify of what to do when the expression evaluates to 0. That's the else statement. Are we doing okay so far with this syntax? Yep.
Do you have to write the else statement inside the brackets like that?
No, the square bracket is what we call Mettre Syntax. It simply means the else portion is optional. Okay. All right. So now that we have described what we call the Mettre Syntax of a conditional statement in C and C++, and we understand what an expression statement is, we also understand what a block statement is. Let's go through a few examples, and you guys tell me what the code is supposed to do. Okay. So we'll go through, the first one first, which is if x equals to 5, y gets 2, semicolon, and on the next line, I have z gets 4. Okay. So this is the code, and I'll give you 2 scenarios to run this through. Okay. So you have to tell me what happens if x is 5, okay, that's one question. What happens if x is, I don't know, 15, okay? All right, so let's go through these two scenarios and find out what happens. And I will also give these things line numbers, just so that we can refer to the line numbers when we execute the code, okay? All right, first case first, which is supposed to be the easy one. If x is 5, okay, x equals to 5 as an expression evaluates to true or non-zero, okay? We just say that it's non-zero, but true is just fine as well, okay? So if the expression inside the parentheses is non-zero, where do we go? We go to line 2, because that's the then statement, right? That's the statement that we have to execute when the condition itself is non-zero. So the execution order is, we start with line 1, the condition is non-zero, otherwise known as true. We go to line 2, okay, y gets a value of 2, and then what do? We go to line 3. Okay, here's the question. Is line 3 a part of the conditional statement? It is not a part of the conditional statement. Okay? All right, so we go to line 3, because it is not a part of the conditional statement, z gets a value of 4. So that's what happens when x is 5 to begin with. So let's take a look at what happens when x is 15 to begin with. On line 1, the condition is false or 0, okay? So we say this is false. And then where do we go? We go straight to line 3, exactly. Z gets 4, we just skip line 2. So are there any questions about this particular scenario? Yep.
So
Go
why
ahead.
does Z get 4 even though it's
Because it is not a part of the conditional statement.
okay.
We actually have, at the top level, we have two statements. We have the conditional statement, which goes from line 1 to line 2, and then we have an assignment statement that is next to it on line 3. So if you are to draw a picture, I really do not recommend drawing pictures, well, at least for the most part of this class. At the beginning, it's okay, but you really should not be using pictures to help you understand the logic after the first few weeks, okay? So right now it's okay, because it's a better tool to understand this particular logic. So what happens with this code here is we have, every time you have a conditional statement, it's a branch. You come in through one path, and then you have two alternatives to go. In this case, we have one alternative on this side, which is y equals 2, right? The other side has nothing to do. There's no else branch, because I don't see the else keyword here whatsoever. So that means I am not specifying what to do when the condition is false. When these things are done, one side has nothing to do, the other one says y gets 2. When they're done, they merge back into one single path, and the statement after that one is z equals 4. Z equals 4 is 3. Go. Okay. And what we also want to specify is here, which is x equals 5. This is the path to take when the condition is true, and this is the path to take when the condition is false. So if you want to draw a picture to represent the logic of those 3 lines, that's how the picture should look like. And, yep.
How are you going to include line 3 in the conditional statement?
Aha, that's a good question. I'm not going to answer that question just yet. There'll be some discussions of that later on, okay? But a clue to that is you can only have one statement in the then portion, which seems really limiting. But we also have a particular type of statement, which is considered as one, but it really is a container, and you can have as many things as you want inside it. Do you remember what it was? A block statement. A block statement starts with an open curly brace, it ends with a closed curly brace. And it serves the purpose of a folder. So inside a folder, you can have individual files, which are our expression statements, but you can also have a single folder. But that one single folder is considered as one item. And you can have a block statement as the then statement. Then you can stick as many things as you want inside the block statement. So, but I'm not going to illustrate it just yet. I'm going to go through this part first. Okay. Okay. Before we move on, I also want to talk about this little code here, and see it from the perspective of the compiler. Okay. This is something that you may or may not get in the next classes, but I tend to do this type of explanation from the perspective of the compiler, because one, I used to write compilers, okay, so I can understand from the perspective of the compiler what happens. But I think more importantly, once you understand how a compiler parses the code and interprets the code, it makes it easier for you to make use of the language features and avoid all the ambiguous features, or at least be able to pinpoint, oh, okay, it looks like it should be doing this, but it really is doing something else, because that's how the compiler sees it. Okay, so let's go ahead and take a look at what the compiler would do. The compiler starts with looking at this word here, if. Okay? If is one of the what we call keywords in C and C++. In other words, you cannot have a variable that is named if. You cannot have a subroutine that is named if. If is specifically, a name used for the starting point of a conditional statement. Is that part okay? So do not use if, for anything else. Okay, it can only be the beginning of a conditional statement. Now, because of that property of the word if, okay, when the compiler sees this word first, then it will automatically understand and say, ha, I am seeing the beginning of a conditional statement. So right at that time, the compiler would have expectations of what to see next after the if word. Is that okay? So that sets up the expectation. What kind of expectations are we talking about? This kind of expectation. The compiler will now say, I should be seeing an open parenthesis next, and then I should see an expression, and then I should see a close parenthesis, and then I should see one then statement. These are the things that I must see. These are mandatory, required. And then optionally, I might see a word else. Now, if I do see the word else, then I'm also going to expect a statement after the else as the else statement. That's what the compiler is thinking as soon as it sees the word if. Okay, fine. So getting back to the example here. So the compiler is pretty happy, right? It sees open parenthesis, it sees the expression, it sees the close parenthesis, and then it says, oh, okay, so what should I be expecting at this point now that I have seen the close parenthesis of the condition? I should see one single statement. This is an expression, now it becomes a statement, right? Because an expression statement is just an expression with a semicolon at the end. That basically makes the compiler happy. The compiler says, okay, I'm at the end of the then statement. What can I possibly see next to this? Optionally, I can see the word else, okay? But instead of seeing else, what am I seeing? Z. Z is not else, so the compiler right here would now say, okay, I have seen the end of the conditional statement already. Because the only one thing that I can possibly see at this point is else, and I'm not seeing else. So at this point, by seeing Z instead of else, the compiler says, I'm done with the conditional statement. That makes Z equals to 4 a statement, not inside the then branch. It is now it's sequential to the conditional statement. It is after the conditional statement itself. But this can be extremely confusing, right? Because to us, what if I do it something like this? I put indentations to visually suggest that line 3 is a part of the conditional statement. The compiler doesn't care. The compiler does not really care about how much space you put on a line for indentation purposes, because this is a C++ program. It is not Python. Indentation is insignificant. Line feed, the end of line, is insignificant. Okay. In other words, I could have typed this entire program like this. And in fact, even this space is not required. So I'm going to use the minimum number of space here. The compiler would look at this single line and interpret it in exactly the same way as those 3 lines. Because to the compiler, it doesn't need the spaces. It does not need the line feed or the new lines. It just goes by the rules of what we specified earlier. So, yep, go ahead.
For example, what if we didn't have that semicolon? What would the compiler do?
Without the semicolon?
Yeah.
Which one?
The first one, after the y equal to.
Without the semicolon?
Yeah.
Okay, so without the semicolon, I'm just going to remove it just for the purpose of the discussion here. So without the semicolon, the compiler will see the if, and then it says, I'm expecting open paren, I'm expecting an expression, a close parenthesis, and a statement here. So at this point, it will say, okay, I got an expression, which is okay, because an expression can turn into an expression statement, just having a semicolon at the end. But it's not seeing that, right? So instead, what does it see next? Z. And there's no construct in C and C++ that has this particular structure. So as soon as the compiler sees Z, it will complain and say, this doesn't work, okay? I cannot expect a identifier, a name, okay, right after the end of one expression.
Okay, so that means that we're gonna have an error?
Yes, you will have a syntax error.
Okay, because I was thinking it might assign the value 2 for y and 4 for z at the same time.
Okay,
so
I see what you want to say.
Yeah.
You can put it there.
Okay.
Now that makes it even more confusing because, okay, so what do you think the compiler is seeing now? The compiler is now seeing, the first part it doesn't change, but I'm going to say it anyway. The compiler will first see the word if, so now it knows what to expect to follow. Expects open paren, okay, we found it, that's good. Expects an expression, good, we found it. Expects a close parenthesis, fine, okay. And then it expects a then statement, a single statement, right? So instead, it finds an expression. The compiler is not going to complain because an expression can turn into a statement just having a semicolon next to at the end, right? But instead of a semicolon, it finds a comma. The compiler says, hey, not a problem, because comma is considered an operator in C and C++. You can use a comma to separate expressions, and that whole thing, the comma separated list, becomes an expression itself, right? So the compiler is not going to complain and say, okay, I guess a comma can only be used to separate expressions, so I'm expecting another expression after this one. And what does it find? Hey, another expression. Not a problem, right? At the end of this expression, it finally sees a semicolon. That semicolon is going to turn y equals 2, comma, z equals 4 into an expression statement. And that expression statement in return becomes the then statement of this particular conditional statement. So the compiler is going like, not a problem, but the code now behaves differently, because z equals 4 is only going to perform when the condition is true. It does not perform when the condition is not true. So by changing, but this is good, okay? I'm glad you asked the question, because by changing a by changing a semicolon into a comma, we have now changed the path of execution or the meaning of the whole program completely. Whereas in English, okay, if you're writing in an English class and you use a comma instead of a semicolon, your professor will kind of ding you for that, okay? But for the most part, the meaning of the statement or the sentences would not be changed to a point where it is completely different from what you intended. But in programming, it does that. Yep.
So by putting the comma instead of the semicolon, you combine line 2 and line 3?
Exactly, because a comma is an operator. It combines expressions into a comma-separated expression. And that's why it can be very confusing if you stick a comma into here. Yep.
So it won't just do the z equals 4, isn't that what you said what the comma does? It just does the last bit of the expression?
If I have a code like this, the picture corresponding to this is now, I'm not going to repeat, the portion that is common, okay? But it does become something like this, okay? Because what is happening here is the then branch is now y equals 2, comma, z equals 4. That becomes a compound expression or comma separated expression. The most important part to remember is comma is an operator. In other words, syntactically speaking, it is kind of like plus, minus, divide, multiply, and stuff like that. So that turns y equals 2, comma, z equals 4 into one single expression. And since it's a single expression, it belongs together, right? The semicolon turns that expression into a statement. So now the code, the structure of the code looks like this instead of that one. So just to make this extremely clear, this is the one with a semicolon, and this is the one with a comma. So those are all very, very good questions. Thank you for asking that, because if you didn't ask that question, I would not even thought of writing this as an example to show people how a single punctuation can change the meaning of the program significantly, actually in this case. So I'm going to take row today. This is the row sheet. Here we go. All right. Are there any other questions about this? Yep.
Earlier you mentioned that if you have a list separated by commas,
Uh-huh.
the last variable.
Only the value of the last expression is the value of the comma separated expression. So when you have 1, 2, 3 as an expression, the value of the entire expression is 3. Okay. All right. So let's go ahead and take a look at some other examples. So we'll take a look at another example that is not confusing, and then we'll try to make it confusing. Okay, so this is the other code. And we'll ask what happens if x is 5, and then we'll ask what happens when x is basically not 5. Okay, that's what I'll do. It's just what if it is 5 and what if it is not 5? That's all I'm going to ask. Okay, so the question now is what if x is 5? But before we try to run this code through our minds, what we'll do first is to analyze the syntax or the structure of this code from the perspective of the compiler, okay? Because I really think that is important to understand how the compiler sees the code, and because otherwise, we see it the way we see it, using indentation and other types of visual cue to understand the structure of the code, but the compiler doesn't do that, okay? So let's start with the word if here, okay? Just like last time, okay, when the compiler sees if as the beginning of a statement, it says, oh, okay, I know this. This is a conditional statement. And not only that, I know what to expect after this, okay? Open paren, expression, close paren, a then statement. Optionally, else and an else statement, okay? So the compiler, with those expectations, the compiler goes ahead and finds, oh, okay, open paren, cool. Expression, cool. Close paren, cool. Then expression, okay? Now this is an entire statement, okay? This is the then statement. Sorry, I should have said the statement. This is an entire statement. So by the time the compiler is finished, parsing this semicolon, it is done looking for the then statement. In other words, if you refer back to the syntax of the general syntax description of a conditional statement, it would have found the then statement by the time this semicolon is accepted or parsed. Okay? So at this point, what is the compiler thinking? The compiler is thinking, hey, I can optionally see the word else to indicate the beginning of the else branch. Or maybe there's no else and this statement is all done. Okay? In the first case, there's no else, so that means line 3 really ends, well, if I change it back to the semicolon here, line 3 is the beginning of the next statement. It is not a part of the conditional statement. But in this case, hey, guess what? The compiler says, oh, there is an else here, okay? So with the word else indicating, yes, there's an else branch corresponding to this conditional statement, now the compiler will say, this is the else statement. This is what I do when x equals to 5 is false. Is that okay? All right. So now that we understand the structure of the code, then it's easy to figure out what the program is going to do. If x equals to 5, then execution goes like line 1. The expression evaluates to non-zero, which is true. Then we go to line 2. Y gets the value of 2, and we're done. Because you only take one of the 2 branches. You cannot take both branches of a conditional statement. You just take one of them. Once we take the then branch, the else branch is not followed. The alternative, which is what if x does not equal to 5 to begin with, is pretty much the same thing. The expression in this case evaluates to 0, which is false. And I have a typo here. There we go. And that means I have to go to the else branch. So the else branch is on line 3, but I typically do not indicate that we trace line 3 because else really doesn't do anything. The word else is more of a separator than anything else, okay? The purpose of the else word here, the only reason why it exists is to act as a separator. It separates the then branch from the else branch. Because without the else word here, there's no indicator whatsoever where is the end of the then statement and where's the beginning of the else statement. So that's why when I trace a program, I do not trace the line that has the else keyword because it really doesn't do anything useful. But we get to line 4, and when we get to line 4, y gets a value of 4, and we are done. Are there any questions about this little code here? No questions? This is all good? Okay. You know what? I just remember I made a mistake. After y gets 2 in the then branch, I just remember, z is supposed to get 20. Okay, so I'm going to go back and fix this program. Okay, so I'll go ahead and fix the program. So the new fixed program is going to look like this. Okay, so I'm going to say, we'll just put z equals to what? I said 20, right? Okay, we'll just put it here and make that line 2.5. Hey, it just has to go between 2 and 3, right? Some of you remember what BASIC used to be. You have to specify the line numbers. So you have to say line 10, line 20, line 30, and so on. So when you insert a new line, you just say, well, pick a number between those 2 line numbers, and you'll be fine. Not Visual Basic anymore. Okay, BASIC is not quite the same as what it used to be. Okay, so the new program looks like this. Okay, what do you think is going to happen when the compiler gets a hold of this code? Well, let's take a look. Okay, let's take a look at what the compiler will think about this code. Let alone, because we have to analyze the structure of the code first before we even try to run it. Okay? So the compiler sees if and says, okay, this is a conditional statement. I know what to expect. I'm expecting open paren, expression, close paren, then statement, optionally else, and then else statement. Okay, that's exactly what we talked about earlier. In fact, I'm just going to copy and paste this so that we have a reference of this, syntax description right about, the actual code that we're supposed to deal with. Okay. Not a problem. Okay. If it's a word that we understand, open paren, matching this open parenthesis here. We have an expression. Okay, that is as expected. Okay, not a problem. Close parenthesis, as expected. We have an expression, not as expected, but hey, semicolon finishes it. That's our then statement, okay? Oh, wait, hold on a second here. Y equals 2 with a semicolon is the entire then statement. So that means when the compiler sees the word z, it will think that, oh, okay, we are done with the then statement. We have an optional else statement, right? So when the compiler sees z instead of else, the compiler will answer its own question and say, oh, this conditional statement has no else branch. And then it will start to parse z equals to 20 like the very first example that we had where z equals 20 is considered another statement that is next to the conditional statement. It is not a part of the conditional statement. And the compiler will gladly compile z equals to 20 as a statement after the conditional statement. And then it sees the word else. And the compiler is asking itself, Okay, what kind of statement can start with the word else? Nothing. No statement in C and C++ can start with the word else, and that is when the compiler will complain and say, we have a problem. Okay? And in this case, it's a good thing because it is not even valid syntax. So syntactically, this is wrong. The compiler will complain about it. It cannot do something that is wrong. The program cannot behave incorrectly because it cannot even run. Are we doing okay so far? Okay. So let's go ahead and retract this example here. Okay, so we'll go back and say, oh, okay, that's not how I'm supposed to fix a program. And the way I'm supposed to fix a program is, oh, you know what? In the else branch, there's one other thing to do. So the other thing to do in the else branch is z gets a value of 30. So z equals to 30 is now supposed to be a part of the else branch. But what would the compiler see? How is the compiler is going to see z equals to 30, line 5? Let's go through what the compiler, from the eyes of the compiler, this is what it sees. If is the keyword, it starts a conditional statement. It indicates what the compiler can expect after this. Open paren, expression, close paren is this part here, okay? It's all good. Y equals 2 with a semicolon is our then statement. It fits this requirement. So at this point, the compiler is thinking, okay, optionally I can see the word else. And it does find the word else, not a problem, right? So after the word else, it is expecting a single else statement. It sees y equals to 5 and a semicolon that turns it into a single statement. That meets the requirement of else statement. And then it sees the z, and the z equals to 30 is now the beginning of a statement after the conditional statement, not as a part of the else branch anymore. Now the problem with this one, as opposed to the earlier example, is this is actually valid syntax. You can have whatever statement you want after a conditional statement. The compiler is not going to complain. But from the indentation, which is the visual cue that z equals to 30 is a part of the then branch, so now the visual display of the code is no longer reflecting its actual structure of the code. This will compile, it will run, but it doesn't do what you think it should be doing, which is z equals to 30 being a part of the else branch. And this is probably the worst type of problem because the compiler cannot spot the problem. It will just compile it. Visually, it looks like it's going to do it the right way, but it's actually not going to do it the right way. And if anyone has programmed in Python or your main programming language is Python, it makes it even worse because this is the way you specify z equals to 30 being a part of the else branch in Python. It is valid, it's a valid way to do it in Python, but not in C and C++. Yep.
So when the z was equal to 30 within the then statement, could you have fixed it by putting a comma after 2?
You can, well, there are several ways to fix it. If you put a comma here, that would fix, quote unquote, fix that problem, but it's not the usual way people do things. So I'm going to tell you exactly what I would do to kind of fix all of these problems and to avoid these things from happening in the first place, okay? But I just want to make sure that you guys understand how the compiler is looking at the structure of the code. It's not really quite the same way that we look at the code casually, okay? Yep.
Just an example for the y gets a 5, right? It's not 4. For the previous example?
For the previous, oh yeah, this is 4 or 5, sorry. Yep. Okay. All right, so this really is, what I'm doing is I'm giving you, I'm telling you the worst part of C and C++ because someone is going to do it this way, okay, and end up with a problem. So now the question is, okay, but how do we fix all of these problems? Okay. So I'll tell you what I do when I write a conditional statement. This is how I do it. When I write a conditional statement, I start with this. Attack, you may not even have an else branch. And now we have to use the cursor key to go all the way back to the beginning to specify the condition and stuff like that. Well, that's a very small price for me to pay when I'm writing the code, because I now do not have to worry about a single thing about the structure of the code anymore. Okay? Because if I have anything to specify, okay, so I typically have to go back here. Yes, it does involve a little more keystrokes to get back there to put in the expression, and I can put all the then branches here. Maybe the then branch is simple. Maybe it does have just one single statement here where the block statement is not even necessary. But you know what? Typing open curly brace, enter, close curly brace, enter is a small price to pay. But now, if later on I find out that I have other additional stuff to specify, I'm all there already. I don't have to worry about having to put an open curly brace and a close curly brace to turn it into a block statement anymore. Is that working out okay so far? So my reasoning, to me, is worth the extra keystrokes. Okay? And maybe there's nothing to specify for the else branch. In other words, the else branch is now just an empty block statement. I'll just leave it like that. Just in case, later on, I come back and say, you know what, I forgot, there's something to specify for the else branch. Now I can just, stick whatever code I need into the open and close curly braces after else, and I'm all set. I don't have to worry about, oh, is this else, corresponding to that if and so on? It's already there. Are we doing okay so far with, my line of reasoning? Okay. It doesn't mean that you have to program this way. It doesn't mean that you have to agree with my assessment of cost, which is open curly brace, close curly brace, extra lines, having extra keystrokes for the cursor keys, as opposed to the risk that is associated with not using the curly braces. So that is your. It's up to you to evaluate. For you, is it worth the extra keystrokes? Okay. But I have about 20, 30 years of programming experience, and in my experience, based on my mistakes, it is worth the extra keystrokes. Okay, so you guys have to find out what works for you better. Okay. All right. So with this out of the way, now we start to look into something that can be even more confusing. Okay, this is not even really confusing yet. Okay, so let's go ahead and start with something that's potentially more confusing. So, and once again, I'm not using curly braces, okay, because that's what makes it, confusing. So we'll say, okay, if x equals to 5, I have a inner conditional statement, which is, if y equals to 16, okay, and then I'll put, a particular value into z. Z gets, 21. If x does not equal to 5, I'm going to specify z equals to 34. Okay, there we go. And put, oh, wait, we need semicolons. Okay, so that's an easy fix. Okay, so now this program is syntactically correct. But the indentation is telling you one thing, the actual structure of the code is different. Okay, so let's go ahead and see from the perspective of the compiler and see how it is going to see this. Okay. So we start with, okay, let me copy and paste the template, okay, just so that we can refer to it right next to this. Okay, there we go. So the compiler starts with the if, which says, okay, cool, I know what a conditional statement is, I know what to expect. I will expect an open paren, I will expect an expression, close parenthesis, then statement, optionally I can see an else, and then an else statement after that, okay? Just like last time, just like all the other cases. So after this if, the compiler will quite happily parse the open paren, the expression, the close paren, and now it sees another if. Okay, so when it sees the other if, it is when the compiler is expecting the then statement. Is that making any sense? Okay, so it's okay. The compiler says the then statement can be a conditional statement itself. Can be another conditional statement, I should say. That's not a problem. But then you have to remember, the compiler will now remember that as a part of a then statement, I am seeing a conditional statement. Are we doing okay so far with that part? Okay. So now the compiler says, okay, let's take a look at what is in the then statement. The then statement starts with this if here. The compiler says, okay, cool, the then statement is by itself a conditional statement. And it will apply the same rules as last time. with the then statement, which means as the then statement, the compiler will now say, I am now expecting open paren, an expression, a close paren, a then statement, an optional else, and after that, an else statement. That's what the compiler says. And it is now in the mode of parsing the then statement of the overall thing. So what it sees is open paren, cool, expression, cool, close parenthesis, cool, a then statement, cool, and what is the compiler thinking at this point? I can see an optional else. Okay, so now the question is, if it does see an optional else, is that else corresponding to the inner conditional statement, or is it corresponding to the outer conditional statement? It's corresponding to the inner conditional statement, right? So that means this else is corresponding to this if. Unlike what the indentation is suggesting, this is the else corresponding to this if, not to this if here. So that means this particular if has no else, because the else is consumed by the inner if. But why is it behaving so oddly? I mean, that doesn't make sense to me. If and else are like parentheses, so they can nest exactly the same way as you can nest open and close parentheses. In other words, if is like open parentheses because it is basically saying what I see after this is a conditional statement. If you see another if inside, it is the beginning of another nested conditional statement. Else is kind of behaving like a closed parenthesis because it is saying, oh, this statement clearly has an else and this is it. Okay, so that's why these things can nest. So what I will do is I'm gonna write out this code here, but using all the extra parentheses just so that you can see what it looks like structurally. So remember what I said? I do it this way, and since inside this one we have another conditional statement, there's no auto indent with this editor. Kind of pain. I can turn it on, I suppose. Okay, so now I can fill in the actual content. X equals 5 goes here, y equals to 16 goes here, and z gets 21 goes here, and z gets 24 goes here. That is the actual code. In other words, syntactically, this code is basically equivalent to this code here. But one indicates the structure of the code a little bit better than the other one. Are we doing okay so far with this? Yep.
If if y equals 16, if that's the then statement, does it need a semicolon at the end of it?
A semicolon is only needed to turn an expression into an expression statement. A block statement is not an expression statement, so it does not need a semicolon next to it. Is that kind of what you were asking? Okay. Right. Any questions about this example? Because this can cause major confusion too. Yep. Go ahead.
Now that you've got the inner if in block statement, do you need the else, or would the outside, what's supposed to be the outside else, still be put to the inner if?
Okay, so I think your question is, what if the intent is z gets 34 is actually the else of x being 5? Is that your question?
Yeah, like would keeping that if in a block statement without an else, even an empty else, would that be okay, or would it not care? Would it still put the next else to the where it is right now?
Oh, okay, I see what you mean. Okay, so let me copy and paste this and see if I understood your question correctly. So your question is, what if we stick an else here?
Well, I kind of meant like, would a block statement kind of contain an if, like an else outside of it? And it's kind of hard to explain actually.
the nesting has to respect, the end curly brace. Okay, this open curly brace is matched by this end curly brace.
Yeah.
So you cannot have a conditional statement that is partly inside the block and partly outside the block.
Okay.
It's yeah. So if you think about open and close curly brace, it's a folder.
Okay.
So you cannot have a file that is partly in the folder and partly outside of the folder.
Okay.
All right. Any other questions? No other questions? Okay. Okay, so if there are no other questions, I'm going to try to fix this code. Did I copy and paste it? I thought I did. Oh, right here. Okay. So how do I fix this program so that z gets 34 is actually associated with this if here and not with this if here? Yep.
Could you just put like a semicolon after the z equals 21?
Put another semicolon here.
Yeah, maybe on a different line.
Well, the line feed doesn't really matter.
Yeah.
you can put it here, or you can put it on the line before. It still means the same thing. Okay, so let's take a look at what happens when the compiler sees something like this. Okay, so the compiler sees the if, it is the beginning of a conditional statement. Okay, I'm going to skip this part here because it's all correct. When it's expecting a then statement, it sees another if, which is fine. You can have a conditional statement as a then statement of another conditional statement, and that's okay. When it sees this, it is the then statement of the inner conditional statement. Now, when it sees the extra semicolon here, it is considered the statement after this inner conditional statement. Okay. Which means it clearly indicates that the inner conditional statement has no else. Okay. Now, if the inner conditional statement has no else, then the next thing it will do is to say, I'm done with the inner conditional statement. Then it will go back to the outer conditional statement and say, okay, with the outer conditional statement, I've done my then statement already. And after the then statement of the outer conditional statement, it will say, I can optionally see an else. Is it seeing an else here? No, we're seeing a semicolon. So this extra semicolon is not ending just the inner conditional statement. It is also ending the outer conditional statement, which also means when the compiler is saying, okay, I'm done with both conditional statements, both the inner and the outer, then it sees the word else, which means at this point it will be considered a syntax error because this else has no if to correspond to it. Or at least that's what I think the compiler should be doing. Now, how do we check whether my understanding is correct or not? Well, we put it into a program and let GCC add it, right? Let CC go at it and give us the indication. This is why I like programming classes, because things are really black and white. Because if I cannot explain this, I can get into the source code of G++ and actually see it from that perspective and see what it's supposed to be doing. So let's go ahead and look at this one, and I'll type in exactly the same code here. So I'll just say condition.cpp. And this one can be just a regular C program as well, because at this point it doesn't make any difference whether we talk about this as C or C++. It's the intersection of the two languages. Okay, so we'll go ahead and just make a quick example of this. So we got X, Y, and Z. And we need to stick something into X, Y, and Z, otherwise the compiler will complain to no end. So all we want to do is just to give some values to Z. Doesn't need a value because it will be initialized. So we say X equals 5, if Y equals to 16, Z goes 21. Put a semicolon here, put the else here, Z equals to 34, return 0. Okay, so this is the same code as what we have on the whiteboard. On the projector. G++. I'm not even going to bother with the other stuff. I just say, okay, compile it. And it says right there, else without the previous if on line 11. So we go back into the editor, and 11 is this one here. So it does behave the way I thought it would. Yep.
What about a comma again?
A comma? A comma is not going to fix the problem. A comma will still be considered an error. Okay, so the only place I think you can replace with a comma is here, right? But if you replace this with a comma, it is expecting, and get rid of this one here.
It's not a statement.
It's not going to do it because after the compiler sees a comma, it's expecting an expression on the other side. But instead of seeing an expression, it's seeing keyword else, and that's not going to work either. So the way to fix this program, so that it means what it does, it means what we wanted it to do, is to introduce an actual else here with an empty statement. That's the way to do it, because this way, when we parse the inner conditional statement, which is starting with the starting with this if, it will get the expression, it will get the then statement, and then it meets the requirement, it meets the optional requirement of the inner conditional statement. It says, hey, I got my own else. Okay, cool. What am I supposed to do with this else? Nothing. That completes the inner conditional statement. So when this becomes one single statement, which is the then statement of the outer if, then the compiler can come to this else here and say, hey, I can still have an else here because this else is corresponding to the if of the outer conditional statement, which is not done yet. Okay, but that's my theory. Okay, so it's best to test it and make sure that the compiler does consider this program to be okay, and it does. Okay. But why bother with empty statements? Just a semicolon and all the kind of awkward-looking else and whatnot, when we can just use open code with block statements. We can fix everything, and everything is so much more clear. Okay. Are there any questions about conditional statements? No questions, or are you guys still processing? Because this stuff requires a little bit of time to process, but one thing you do want to kind of remember is if it's sort of like open parentheses, because it is the indication that, hey, we can have some stuff inside, okay, and things can nest after this. Else, on the other hand, is kind of like close parenthesis. It's not exactly the same thing, but the way you match if with else is the same way you match open parenthesis with close parenthesis. So if they're nested, then you have to match the innermost else with the first if that is not open. Well, that is not closed, sorry. With the first if that is open. Just like you match parentheses. The worst part of this stuff is some statements may not have an else. So that way, you can that's the source of a lot of problems. Yep.
I think I missed it if you said something. If you're doing block statements with the curly braces, do you need the semicolons then?
No, you do not. Because the semicolon is needed only when you turn an expression into an expression statement.
So it's already a statement.
Because a block statement is a statement already, you don't need a semicolon. Now, syntactically, if you stick a semicolon after an end curly brace, syntactically it is okay, but the semicolon is considered a second statement. Which means, in a case like this, if I put a semicolon here, that would not be a problem, okay? But if I stick one here, that will be a syntactical problem. Because what happens here is, when the compiler sees that semicolon, it will be indicating the end of the if already. So when it sees the else, it will go like, whose else is this? Okay, so even though in many cases you can stick a semicolon with no ill effect, there are places where if you stick an extra semicolon, it'll go like, the compiler will just kind of fall apart. And this is why I claim that C++ is not really a good beginner's language, because I would not design a language like this, okay, for beginners. I would say that if you have an if, you are mandatory to have an if as a statement to end the block of if, okay, and you cannot just do stuff like this, like in what we can do in C++. All right. Any other questions about this stuff? Let me give you another program that is faulty, and you tell me what it is going to do, and it has to do with conditional statements. Okay. So I'm going to give you this x equals 5. Okay. And over here we say, z. Okay, so this is the program, okay, and I'll give you the condition of the program too. Okay, so I'm gonna say assume x is 0 to begin with. Okay, tell me what this program is going to do. Yep.
You don't have a double equal sign on the if, is that?
That is intentional. Okay, so we start with line 1. So line 1 is now doing, is syntactically correct, okay? Because x equals 5 with one single equal, which means x is getting the value of 5, is an expression. As an expression, it returns a value. The value it returns is whatever is on the right-hand side, which is 5, right? So that means the expression is considered to be true. So line 1 is now doing two things, neither of which is what we want it to do. The first thing it does is to say x gets a value of 5. First wrong thing to do. Second thing is 5 is non-zero. It is true. So now it will go to line 2 because, hey, you know what? The expression is non-zero. It is true. We go to the then branch. The then branch is now going to say, does y equal to 15? So now I have to say, assume y is, doesn't matter. 35 to begin, 23 to begin with. Okay, so line 2 is doing what it is supposed to do. Okay, it will compare y to 15. So y equals to 15 is not true. Then we move on to, we don't go to line, this is line 1. This is, well, that's actually line 3, sorry. So we are done, actually, in this case. There's nothing else to do. But when your program runs like this, it is not only taking the wrong path, it will also change the value of x. Instead of keeping the value of x being 0 and just take the wrong branch, take the wrong turn, it is changing the value of x. And this is a very common error because all it takes is forgetting to type an extra equal symbol when you mean comparison. Okay? And I cannot tell you how many times I have done this. Okay? So what are we going to do with this? It's like, hey, you know, this, if it is such a common mistake, and it is so nasty as a mistake too, because if you think about this, this is easy to spot, okay? You know, because I have an equal here, single equal, and a double equal here, and then your eye will just pick it up. It's like, oh, single versus double. Which one am I supposed to use? And then as soon as you question yourself, you'll figure out the answer. But what if this is inside a huge long expression, and the next line does not even have a double equal? Then it becomes a lot harder to spot it, okay? So if it is so difficult for us to spot, and this is such a nasty problem, somebody needs to do something about it. Let's see what the compiler is going to do about it, okay? So we'll go ahead and say, you know, vim, confuse.cpp. Well, it is kind of confusing. So we'll say int main, same thing, x, y, z, and if x equal to 0, y gets, you know, 23. Okay, so that's enough already. Okay, because I just want to illustrate a feature of the compiler that you can make use of. Okay, so we'll exit here, and we'll say g++ -c confuse.cpp. The compiler does not even say a single thing about it. Well, I forgot the usual things that I usually do, right? Warn all. Now the compiler complains about it. Okay, the other two are not related, but the first one is. Warning. Okay, let me get the other part here. Okay, warning, suggest parentheses around assignment used as truth value. Okay, so I know it's kind of obscure, an obscure way to complain about it, but the fact that it mentions assignment on line 5 should be a clear indicator that, okay, did I mean assignment? Okay, so what it means is if you did intend as an assignment, you put extra parentheses around it. Okay, to double indicate that, yes, I know what I'm doing, just go ahead and do the assignment. Okay? But that is giving you a message, because it's basically telling you, regardless of the tool that you'll be using, okay, I know some of you only have to take this class and no other C++ classes, but many of you will move on to 400 and 430. So what you need to do, regardless of whether you use the command lines G++ or code blocks or any other tools, turn on the warnings and don't ignore the warnings. If you turn on the warnings and ignore them, it doesn't do you any good. Okay? So you gotta read the warning messages and say, okay, is the compiler seeing something that is suspicious and may indicate there's actually a problem? Are we still doing okay so far with this stuff? All right. So we are at the end of today's lecture. There's really not a whole lot of structured instruction during the lab time. So if you're done with the next homework assignment, you can kind of play with this stuff here, because nothing beats actually writing the code and going through GDB and single step through it to find out what it's going to do. So you can do that during the lab time, or if you have not done the homework assignment, this is a perfect time to get started with the homework assignment. And don't forget the quiz that is due earlier today. I extended the deadline. So if you have an issue with that one question that we talked about at the beginning of the class, you can redo that one. Okay, well, you have to redo the whole test, but that will make a consistent answer for that particular question. And that's it for today's lecture. I will see some of you next Wednesday, not next Monday, because Monday is a holiday. Yep. So have a nice long weekend if I don't see you during the lab time.